You're listening to the Common Descent Podcast.
Hello, Will.
Hello, David.
Hello, listeners, and welcome to the Common Descent Podcast, episode 184. This is our first episode of February 2024 and our Darwin Day episode.
Yes.
We have a long-running tradition on the podcast that around Darwin Day, which is February 12th, we release an episode about historical figures. This is a thing we've been doing for a while.
Mm-hmm.
This episode continues that tradition. This episode, the historical figure that will be the topic of our discussion is Richard Owen.
Yeah.
Sir Richard Owen.
Oh.
Indeed. Who is an oft-heard name in the realm of biology and paleontology, a contemporary of Charles Darwin, often portrayed as a rival of Charles Darwin.
Yep.
But not a person nearly as famous as or recognizable a name as Charles Darwin. So this episode, we'll talk about who this person was, what he did, why he's famous, and this often when we talk about historical figures, we end up getting into the discussion of what kind of person are they, how does their legacy square with who they were as a person. Richard Owen's a great opportunity to talk about that, because one of the most famous things about him is that he was supposedly a real jerk.
Yep.
So this will be a whole lot of fun discussion.
I also love when there's those historical, like, these two are rivals, and the second one you go, who? It's like, well, I guess we know who.
Right, yeah, I guess who won.
Who won that rivalry.
Now, Richard Owen is, I actually don't feel like I have a good sense of how well known a name Owens is, because I'm very familiar with that name, because his name's attached to tons of scientific names and scientific papers.
Like, you just see it pop up as you learn about things.
But it is not a household name the way that Darwin is, for sure. So, listeners, feel free to let us know how familiar you were before this episode with this name. This also feels like an appropriate time to do a Richard Owen episode, because the thing that Richard Owen is most famous for is being the person who came up with the word dinosaur.
Which is a pretty big deal.
That is his claim to fame. And it is 2024, which means that this year is the 200th anniversary of the first dinosaur receiving a name.
Which is pretty insane.
Megalosaurus was given its name by William Buckland in 1824.
That's pretty awesome.
So Owen is sort of a suitably fitting person to get to talk to in a year like this.
Yeah.
As with all our episode topics, this topic was requested by our audience. A Richard Owen episode was requested by Nora. Thanks, Nora.
Thanks, Nora.
Before we get into the main episode, a few announcements. First and foremost, our podcast is supported by Patreon.
Mm-hmm.
All of the things that we do for the podcast, all of our science communication efforts are made possible thanks to the amazing support that we get from our patrons. This episode comes out just after we have celebrated our 7-year anniversary of the podcast. Thank you all so much for making it possible for us to keep going so long. We got to do our 7-year live stream. We got to announce the winners of our Patreon giveaway, so congratulations to those folks. And just a huge thanks to all of our patrons as always. If you decide to support us on Patreon, there's a whole bunch of goodies that you can get as benefits. Bonus recordings, special merch, mini episodes, getting to ask us patron questions, and so on. One of the benefits you can get is a shout out here at the top of the podcast. This episode, we would like to shout out and welcome new patrons, David, Jonathan, Brian, and Jennifer.
Welcome, everyone. Thank you so much for supporting us.
There are a few more things coming up that we can announce. For one, in March, we will be at ETS Yukon.
Yes.
In Johnson City. We're going to do some more presenting, talking about dinosaurs and biology and stuff like that. So if you're in the Johnson City area and you want to check us out, we will be there. Also, as we announced on the anniversary livestream, we have a new series coming up. We are bringing back Spotlight for the first time since the first time that we did it, which I think was 2018. Spotlight 2024 will be themed around the topic of science communication, and we're going to be talking to a bunch of other podcasters. Stay tuned for future announcements about those episodes as they are ready to come out.
Yeah, it's gonna be good.
And that's enough announcements for this episode. Let's get into the news Every episode we start by talking about some recent news in the worlds of paleontology, evolution, biological sciences, the things we like. Keep us all up to date on what's going on. Will, news.
I have a quick one as my first news about a new species of temnospondyl, those big amphibian cousins from the Permian and Triassic. And this one was found in Brazil, which ends up being important. This research is by Felipe Pinheiro et al. In the Anatomical Record, and the article we'll be linking to in the blog post. There's a blog post. Is by Enrico de Lazaro in Sci News. So temnospondyls were a group of often kind of crocky-shaped amphibian cousins. They were around in the Permian and into the Triassic, which makes them interesting for study because that they were one of the groups that survived the in-Permian extinction.
Mm-hmm.
And so looking at them for what made them successful and all of that has been an interest. But the researchers note in the paper that some of that history isn't well known because of under-surveying of certain sites that might give us more information. This new fossil is from one of those more poorly known sites. This is the Sanga do Cabral Formation in southern Brazil, which is an early Triassic fossil site, and the new species and genus of temnospondyl they found is named Quatasuchus rosei, and is just a fossilized skull. It dates to about 249 million years old, so lower Triassic, and is estimated to be approximately 1.5 meters long, so like just under 5 feet.
The whole body, I assume.
Yes, yeah.
Extrapolated
Estimated
from the skull.
from that skull is the animal is estimated to be just under 5 feet long, and it's once again very crocky looking. The skull, the snout is shown in the paper in the article, and yeah, it looks just so crocky. I'm always blown away by how similar they are. They even have similar texture to them.
Mm-hmm. Yeah, the original crocs.
Yup. They were able to confidently assign this to a group of temnospondyls known as the Benthosuchidae, which are stereospondyls, specific clade known during the Triassic, but their distribution previously was only known from the East European platform. So this is a new area, range extinction. They did phylogenetic analysis to place them further, and it confirmed their relationships with a lineage called the Traumatosauриans, which are closer related to a genus of Benthosuchus, so very solidly placed within the temnospondyls group, this temnospondyl group. But it raises questions about how they were distributed, and they said that this suggests a potential connection between Russian and South American early Triassic faunas.
Interesting.
If we're finding a group that was only heavily known from one area in this new area, there may be a connection between those areas that we weren't aware of. But they emphasized that further investigations are needed through more of these poorly known sites, these Gondwana and these southern hemisphere sites, to try to get a better image of their range and the distribution patterns.
Yeah, it'd be especially interesting to see if there are any sites between the Eastern European regions and South American regions where they may have been pathways that they had filled out.
Yes, precisely.
Well, that's pretty cool. I also have a news about a new species of a thing that adds more diversity to a group of ancient animals.
Nice.
Mine's a dinosaur. Specifically, a sauropod dinosaur. It's one of the ones with the long necks and the long tails from a lesser-known group of sauropods, of which this one is an odd entry. This is research by Lucas Nicolas Lerzo et al. In Historical Biology, and the article linked in the blog post is in Live Science by Patrick Pester. This new sauropod belongs to a group called Rabachisaurids. This is a group of sauropods that are known mainly from the early Cretaceous of southern hemisphere continents, Gondwana, especially South America. Rabachisaurids belong to a broader group called Diplodocoids, which includes 3 major lineages: the Diplodocids, which has your Diplodocus, Apatosaurus, and so on. Their close cousins, the Dicraeosaurids, which has Dicraeosaurus, Amargasaurus, the one with the big spines on the neck, and then one step out from those two are the Rabachisaurs. So that is the sort of family, it's a semi-extended family of these group of dinosaurs. This lineage often have these sort of broad faces. I've seen them described as duck-faced.
Oh, yes.
This includes, for example, Nigersaurus, which has that broad front of the face. They're interpreted as probably feeding close to the ground and sort of lawn-mowering up low plants and such. This study identifies a new Rabakisaurid, which is named Cytosaura mare, a new genus and species from Argentina, from the Huincul Formation, which is 96 to 93 million years old, the early late Cretaceous. The fossils were first discovered in 2012, then several years of excavation ended up pulling up pieces of 4 different individuals, all together showing many various different parts of the body. The researchers were able to identify unusual features in the skull, the legs, the tail vertebrae, which is where the name Cytosaura comes from. It means star reptile, referring to the shape of certain projections on the tail vertebrae.
Cool name.
Those features were able to identify that this is something distinct from all other known sauropods. It is also unusual for 2 main reasons. First, they also did a phylogenetic analysis to compare it with other known sauropods, find out where it fits on the tree, and their analysis suggests that it is a basal Rabakisaur, so it is a member of an early branching lineage of the group, more distantly related to most of the other species in this group. But these fossils are very late for this group. They're actually shortly before this group goes extinct, which suggests that some members of early branches of this group survived basically throughout the whole history of this group of sauropods, which we didn't know before, which is a pretty cool thing to see.
Cool.
They're also unusual for their size. The researchers estimate that this species would have gotten up to possibly 65 feet long, so about 20 meters and 16 tons, which is it's huge. It's a sauropod. That's very, very big. That's not preposterously large for sauropods. There are many that get bigger, but it is unusually large for Rabakisaurids. Most Rabakisaurs tend to get up to around 10 tons, so this one is quite a bit larger than the typical members of this group. Which is interesting because it tells us something about the diversity and evolution of this lineage. And for me, and I didn't see this mentioned anywhere in the paper or the article, but we've talked before, especially in our Sauropods episode 101, that sauropods are famous for getting very, very large, but that is something that has happened multiple times in different groups of sauropods.
Yes.
And this made me also think, oh, is this yet another lineage of sauropods that got surprisingly large, independent of their relatives?
Yes. I also had the thought of wondering, because this one is around after a lot of the other members of its group had gone, if there was any connection between its success and it being bigger.
Right. Or is there any connection between its size and its early branch? Does this suggest that early members of this group were big, and this is one that hung on to that?
Oh yeah, good point.
Or is this a lineage that got big and that is what allowed it to survive as long as they did? Yeah, it adds an interesting piece to the puzzle of this species.
It's always cool to find an edge of the bell curve member for a group that adds that really intriguing new data.
Yeah, it's an interesting one to talk about because the discussion of it starts with, here's this group of dinosaurs you probably have never heard about. Let's introduce those. Here's this new animal that is a weird member of that group that you just heard about for the first time.
That is not actually a great intro representation. Yes. My next bit of news is also dealing with dinosaurs, but this is an odd study. This is dealing with a robot dinosaur to try to interpret feeding strategies and the use of feathers.
That's very cool. I saw this one on the news list and I left it for you.
Yes.
Intentionally.
Yes. No.
Even though I just did the feathers episode, I was like, sure, but this has robots and I know Will will really enjoy it.
No, this one's a cool one. This research is by Jin-Suk Park et al. In Scientific Reports, and the article is by Kylie Price in Live Science. So, we talked about in feathers, and we've talked about this in a number of other episodes, that there were lots of feathered dinosaurs that were not flighted. And the question of what were you doing with these feathers, if not flight,
Right, especially the ones that had like wings of
Yes.
feathers on their arms.
That had what seemed to be quote unquote functional feathers, feathers that should have been able to do a similar feather job to what we see today on birds, but on an animal that definitely could not take off with flight. Was too big, too heavy, and didn't have enough feathers to do it. So there's been lots of ideas. These researchers were looking at a particular kind of behavior used by some birds today, where they use their feathers to flush prey out of the underbrush, flapping their wings at the underbrush to scare prey out and then catch them. They noted particularly that this is known to be used by the greater roadrunner, and it's sometimes called the flush pursuit strategy. You flush them out and then chase it down.
Okay.
And we're suggesting this could be a valid use for these four-limb wings, these wings on the arms, to flush out prey. And so to test that, they built a robot. They built a robot nicknamed Robopteryx, which is made to resemble Caudipteryx, which is a smaller-sized dinosaur with wings, feathers on its forelimbs and a plume of feathers on its tail.
Yeah. Caudipteryx is part of the Oviraptorosaurs,
Yes.
which include the species that have been found sitting on nests of eggs with the arms out to the sides, which has led to the hypothesis that that one use of those feathery wings may have been to protect their nests while they sat on them.
Yes. This one was around in the early Cretaceous, somewhere between 125 to 122 million years ago. They made a robo version with wheels so that they could move it around, and black felt body, and arms that could flap, and they, as they put it, unleashed the robot on a group of grasshoppers to see how well this flapping motion would get the grasshoppers to flee in a means that could then allow them to be pursued and caught. They tried it both with and without wings, so they could add wings and take them off to see if it would have worked perfectly well with just arms, and so the wings weren't actually making a difference. When they did it without wings, they said less than half of the insects dashed away, so not a ton, but when they added wings, they noted that 93% of insects fled.
Wow.
So the wings made a huge difference with flushing the prey out. They recorded these responses into a computer animations and to be able to compare and mark the behaviors, what they called their neurophysiological responses. Basically, they're studying the fact that a lot of prey animals have neural pathways, paths in their brains or, neural nets in this case, that trigger escape responses with certain stimuli. And that this flapping is likely triggering that run, even if you don't know what you're running from. And they tested it out with different proto-wings and noted that they were very effective, especially if the wings were at the ends of the arms and with contrasting patterns. So if there was patterning on the wings, on the feathers, that made a difference. They also noted that if the tail feathers were used and had a larger area and used during these flapping displays, it was also more effective. So there seems to be some support that this behavior gives us another purpose for these tail and arm feathers that's not flight-based.
That's really interesting. We've talked about this a bunch on the podcast, that feathers on early non-flying dinosaurs probably had tons of different functions that they were used for, display or insulation. And very often what we end up doing is we look at birds today and go, hey, there's a thing that birds do with their feathers. Those dinosaurs very likely could have done that too. This is an interesting case where we looked at a bird today and said, yeah, it seems to be doing this with its feathers. And these researchers have gone, well, let's see if that thing we're watching it do actually does require those feathers to work efficiently. And are finding that, yeah, it seems that having feathers there does help with this strategy.
They pointed out that this also gives us a evolutionary path that we could predict, that stiffer and stronger feathers would allow for more aggressive flush displays and flapping. And if you're also then chasing the prey down, could help with that maneuverability that has been proposed for them with running and turning.
Right. This is one more function that could have added a selective pressure for more broad, powerful feathers that could later set the stage for flight.
Precisely. They call this the flush pursue hypothesis and have kind of put it forth as a new or additional hypothesis among the many others for the distribution, on the body of these feathers and their evolution and similarity to flight feathers, flight-like features. But people have brought up notes about this study. One particular researcher, Jingmai O'Connor, pointed out that they didn't have an issue with the study overall, but that we actually do not have direct evidence of these dinosaurs and their cousins feeding on insects.
Sure. It's possible they did.
Yes. There's no reason for us to say for sure they didn't, but we do not actually have direct evidence of them being insectivorous. Mm-hmm. So this particular study used a prey item that we do not actually have confirmed evidence that would have been what they were going after.
Right. So this could have worked.
Yes.
But it's very difficult to say that this is something those dinosaurs did do.
The one of the quotes they said, which I thought summed it up, was that this is really the only hiccup in the hypothesis. It's good otherwise, but because of that, it's still highly hypothetical.
Yeah.
And they would like to see it done with more types of prey.
Yeah, does this work on lizards?
Yes.
Does this work on whatever else?
Some of the ones that we actually have gut contents for and can confirm they ate.
It's interesting. I have the two things come to mind. One is this is an interesting hypothesis that feels unnecessary to explain the evolution of flight-capable wings, but an interesting additional factor.
Yes.
This is one of those that often something like this will be reported as like, we figured out how wings evolved.
Yeah, why they had those.
And this is a case where there are plenty of other great hypotheses as to what pressures might have driven the development of bird-like wings. This adds yet one more thing to that. The diversity of things you can do with a not quite bird-like wing.
Yes.
Which is really cool. I also had the thought, and I would wonder if the authors put any thought into this as well. The implication of the study sounds like it is that the flapping of feathery wings triggers a flea response in these grasshoppers because it's something about it is just very startling and they run away.
Yes.
But it occurs to me that the grasshoppers they're testing it on are modern grasshoppers who are part of an evolutionary lineage that has been hunted by birds for like 100 million years.
Yes.
In a world before birds were very common, I wonder if that response would have worked.
Yes.
On as wide a group. Is that something that's built in because it's just scary to grasshoppers? Or is that something that's built in because 100 million years of being hunted by feathery creatures has developed this instinct in grasshoppers to flee bird-like things?
Yes, I have the same thought that
in the first feathered dinosaurs, would grasshoppers have not had any particular response to it?
Yep.
No more startling than anything else that's out of the ordinary.
Yeah, I have the exact same thought that these are not the same prey items and they have had a different history. So I like this study because it is a intriguing way to go about it, to test the hypothesis, and is looking at a different avenue than I've heard of, looked at before, but definitely has a couple of key things that need to be double checked and potentially redone with different scenarios to actually make this a more substantial and solid bit of research for everyone to build off of.
Yeah, that's pretty cool. Yeah, well, and they got to build a dinosaur robot, which is always fun to do. One more bit of news. My last news is about woolly mammoths.
Woo!
Well, and in this case, a particular woolly mammoth and the journey that it took over the course of its life. This is research by Audrey Rowe et al. In Science Advances, and we will link to yet another article in Live Science, this one by Sasha Pear. Woolly mammoths, Mammuthus primigenius, are known abundantly from the Ice Age of North America. This is a species that overlapped with humans in North America. In this case, they're studying mammoths in Alaska, and the authors note at the top of the paper that woolly mammoths and early humans on this continent overlapped for about 1,000 years. And there have been lots of questions between humans arriving and mammoths going away about how these species were interacting. This study is an analysis of a mammoth tusk found at an archaeological site in Alaska called Swan Point. This is one of the oldest known archaeological sites in this region, and indeed in the Americas. It's got artifacts, tools, hearth features, animal remains. including the remains of multiple mammoths. The site is interpreted as a seasonal camp,
Okay.
where
Okay.
from time to time, on a regular basis, people may have been coming here to hunt or whatever other activities. The tusk found at this site has been dated to about 14,000 years old, which is right in the time period we'd expect some of the earliest humans to be showing up in the region. As we've discussed before, mammoth tusks grow kind of like trees do, in that they have growth rings within them, so you can analyze the rings of a mammoth tusk and trace changes in their growth patterns or chemistry over the course of their life.
Yes.
Year by year. In this research, they did exactly that with isotope analysis. We've talked before about how different isotopes in bone or tusk or teeth, oxygen, nitrogen, strontium, can be linked to different types of food, different environments, sometimes even different regions of a continent or country, because these animals are picking up parts of their environment as they live and eat and drink, and that affects the chemistry of their tissues.
I always love isotope analysis because it is the scientific version of you are what you eat.
Yes.
That you take in the things you're consuming and it becomes part of you.
So we can say this animal at this time of its life was eating this kind of food, was living in this kind of habitat, or even was in this part of the country or this part of the continent. What they found is that this particular mammoth, which is an adult female, spent its early years in the Yukon, stayed there for about a decade before ending up in the interior of Alaska where this site is, which is notably around 1,000 kilometers or 600 miles away from where it would have started its life. So over the course of a few years, this animal traveled quite a long distance from one place to another. The isotopes also suggest that as it moved, it tended to stick to highland areas. This is based on what kind of isotopes indicate what kind of plants that it was eating. The headlines to a number of articles about this I saw were some variation on this. This mammoth traveled 1,000 kilometers in its lifetime before ending up in an ancient hunter-gatherer camp.
Yeah.
They also took some DNA from the tusk and compared the genetic material with other mammoth remains at the same archaeological site and other sites in the region, and found that this mammoth is closely related to the other mammoths at this site, but looking across the whole region of mammoth material, there seem to be two distinct groups of related mammoths, which might be two distinct herds.
Yes, yeah, makes sense.
That were frequenting this, two distinct lineages frequenting this region, which also lends support to the idea that this may have been a place where multiple herds of mammoths came regularly, that they would have started somewhere else and traveled long distances and ended up frequently showing up in this portion of Alaska. This also, the authors propose, might explain why there is a camp here and why there are many other archaeological sites in this region. It's a very dense region for archaeological sites, that if this was a common place for mammoth herds to be coming through, especially seasonally, it may have been a common place for early human communities to settle at times of the year because mammoths are a great source of resources.
Yes.
You could hunt them for food, for bone, for whatever. So the people in this area may have been following the mammoths to some degree. Now they note there is no direct evidence that this mammoth was hunted and killed by people in this area. It sounds like all they have is this tusk. So there's not like a skeleton with butcher marks or anything on it. But they do note that based on the study of the tusk, this mammoth, when it died, was about 20 years old, which is the prime of young adult life, and there are no signs of poor nutrition or anything in the developing tusk tissue. So it suggests that when this mammoth died, it was doing very well.
Yeah, it was healthy potentially.
It was perfectly healthy. It was a healthy young adult, which doesn't mean that something tragic must have happened, and it doesn't mean that the thing that happened was human hunting, But it does mean that it could very well be. There isn't anything else obvious,
Yes.
like a disease or something. It could very well be that this animal was hunted and killed. It could also be that parts of it were just scavenged and found out there after this animal got, killed by something else.
Yes, there's plenty of ways it could have died that weren't just people, but they cannot be ruled out of the list.
Yes, exactly. So this is an individual mammoth whose tusk tells us about 20 years of its life of traveling across the northern reaches of North America, with hints into the broader patterns of mammoth behavior at this time in this place.
That's so cool. One thought I had during that was the two herds that, the two potential populations that may have been ending up in this area gave me the image I've seen in documentaries of herds of elephants that meet up during migrations.
Mm-hmm.
And, it'll talk about the fact that, this is a somewhat yearly chance for them to reconnect with, acquaintances and friends they've made from other herds that they don't get to see because they don't live together.
Yeah.
And just picturing that happening with mammoths is utterly delightful.
Yeah. Well, and also the thought that this is where all the mammoths congregate either every year or it's on a certain cycle. And while all these herds of mammoths are gathering around common watering holes and stuff, there's a bunch of predators that also come here. All of the mountain lions and dire wolves and early humans who are also waiting in the wings, this is it. This is the time where all the meat shows up.
Yep. Cool stuff.
Very cool studies. That's the news. If you'd like to read those articles, we will link to them in the blog post on our website. Go check it out. Link in the episode description. With that, we can move on to our main discussion. Do a little rewind, which sounds like, I was going to say, let's go back in time, which is a very strange thing to say on a podcast where basically everything we talk about is millions of years ago.
Yeah, from these newses, let's come forward in time.
Now let's come forward in time. Let's rewind the clock about 200 years from now and talk about one of the more distinguished and often discussed and remembered figures in the early history of paleontology, Sir Richard Owen, after the break. If you are a paleontologist or a biologist or a person who's interested in those fields of study, odds are you have come across the name Richard Owen many, many times.
Yes.
This is a name that comes up a lot, partly because he did a lot of really important, influential work early in the history of paleontology, and partially because he named a bunch of stuff.
Yep.
A lot of modern and fossil animal names, including some really popular ones, he came up with. And so his name shows up whenever those taxonomic names come in. When they put the name of the person after the taxonomic name, Owen. Owen shows up all over the place.
Yes.
Richard Owen, later Sir Richard Owen, is a well-known figure from the early history of paleontology. Although I have seen conflicting opinions on how famous he is and what his legacy is. Mm-hmm. I've seen a number of places that refer to him as an underappreciated or under-recognized figure in the early history. But then there are also arguments to be made for him being not a person that needs to be recognized quite as much. Richard Owen is famous for a number of particular things. He is famous for being a pioneer in the fields of comparative anatomy and taxonomy and a part of early paleontology. He is famous for being a champion for museums as a place of public engagement.
Yes.
He is famous for being kind of a rival to Darwin. Kind of. We'll talk about that later. He is famous for being a huge jerk. This is one of the things that he is often... I saw this mentioned many times when I was looking up stuff about him. He is often portrayed as the villain in the story of evolutionary studies and early paleontology. He's the villain to Darwin because he argued with Darwin about stuff, but he's also the villain because apparently he was just a real jerk of a person. We will also talk more about that later on in the episode. But perhaps the single thing he is most famous for, particularly in our circles and for the purposes of the stuff we talk about on this podcast. Richard Owen is the person who invented the word dinosaur.
Kind of important.
That 1842 dinosaur was named for the first time. That is not nearly the only or even most important thing that he did, but it is a very memorable thing that he did. And we'll mention that later too. But let's start with the world that Richard Owen belonged to. Richard Owen was born in 1804. He grew up in the early 1800s. This time period is the early years of paleontology. This is, right, geology and biology have come into their own as sort of early versions of major topics of scientific investigation. By this time, paleontology, the study of fossils, is a thing. The recognition of fossils as the remains of extinct organisms is a thing, but paleontology is only really beginning to get going in the start of the 1800s. Owen is, for comparison with some figures we've talked about in previous episodes, Owen is 5 years younger than Mary Anning and 5 years older than Charles Darwin. Right. Later in his life, Owen would go on to argue with Darwin about evolution, and Owen would go on to pal around with the scientific societies that were refusing to let Mary Anning become part of them.
Man, where's that Animaniacs historical show for kids to teach them about the history of paleontology?
Well, a few decades after Owen, Cope and Marsh are born.
Yes,
that's what the
yes.
Animaniacs
Well,
show is
that's
about.
Tom and Jerry.
Owen was born in July of 1804 in Lancaster in England. He was not wealthy. He was not, which surprised me because so many of these early science figures are people who were born into wealth.
That's usually in the olden days how you were able to do science, is you didn't have to have a job because you had money.
Absolutely. He was not born to a wealthy family. His father died when he was 5.
Wow.
So he got off to not the most auspicious of starts. As a youth, he went to Lancaster Grammar School. A lot of places on the internet like to point out that his teachers reportedly said that he was lazy and impudent, which always fun to hear stories about famous scientists who were bad students. Yeah. That's always a nice thing to hear.
Well, very humanizing.
Well,
like, many of us have struggled in school.
Yes.
And so it's nice to hear that it's like, school was not fun for a lot of people, even some of the famous smarty ones.
Absolutely. He would go on to enlist as a midshipman in the Royal Navy, but ultimately goes into medicine. That's how he gets his start in the scientific fields. In the 1820s, he studies medicine and anatomy. He apprenticed in surgery. He ultimately ends up moving to London and becomes a member of the Royal College of Surgeons. There, he becomes assistant curator to the Hunterian collection. This was a collection of anatomical specimens of humans and other species put together by, at that time, the late surgeon John Hunter. So he's studying surgery, but he also becomes an assistant collections manager for this anatomical collection. The UCMP Berkeley site included this passage that I'm just going to read straight. Unfortunately, a previous caretaker of Hunter's estate, the surgeon Sir Everard Home, had burned most of Hunter's papers and documentation because he had been publishing Hunter's discoveries as his own and was afraid of getting caught. This meant that Owen had to identify and catalog the entire collection anew.
Whoa!
Which is Victorian sciencey folks.
It's a wild west of science.
But also the idea that this grad student effectively went into this new collection and the guy who had previously been in charge of it had just made an absolute horrible mess of it and he had to fix everything is, I think, very relatable. I'd love to share that story with Allie and get her perspective on it. By 1830, Owen had labeled and identified and reorganized all of the specimens in the entire collection. And along the way, it became an expert in comparative anatomy.
Yeah. Because you would, wouldn't you?
That's what would happen. He became really interested in comparative anatomy and starts shifting his focus from pure medicine to anatomical studies. Around this time, he also gets engaged. His wife, Caroline Clift, is the daughter of the conservator of the museum at the college. Owen would eventually replace his father-in-law. They get married in 1835, and I never came across much else about his personal life.
Yeah.
This isn't going to be like the Darwin episode where we're like, and was his kids and his relationship with his... No, we're going to talk mostly about science.
Yep.
Speaking of science. Owen did a ton of scientific work, study, research, starting off in medicine, eventually moving into anatomical studies, fossil studies. He ends up becoming a member of the Royal Society, takes on a number of notable positions, including lecturer at the college, which is where he becomes Professor Richard Owen.
Mm-hmm.
He gives lots of lectures, and this is something that seems to have been a really big aspect of his persona. I saw him described as becoming somewhat of a celebrity scientist.
Okay, yeah.
He gave a lot of lectures which were attended by important people, other scientists, but also just like high society important folks in the community. At some point in his life, I saw this referenced a number of times, he tutors the children of Queen Victoria.
Oh, wow.
So he was a sort of well-recognized and celebrated scientific speaker of his time. He also does a bunch of research. His first paper is published in 1826. It is a medical paper on the calculus of the urinary bladder.
Ooh.
I don't have any further information about that, because then he goes on to make publications about animals and anatomy and anatomical studies and stuff, which is way more interesting than the calculus of the urinary bladder.
Agreed.
In my and presumably Richard Owen's humble opinions. One of the earliest publications that he did in this realm of study was actually describing the anatomy of nautiluses.
Cool.
The shelled cephalopods. He went on to examine animals from all over the world. He was connected to the London Zoo. So he was the person who got the opportunity to dissect the animals that passed away at the zoo.
Yeah.
Which is the kind of thing that continues to this day. A lot of biologists or paleontologists at universities or museums will often be connected in communication with local zoos. It's like, yeah, if your rhino dies and you're not doing anything with it, that could be really helpful for us in research or education. Over the years, Owen publishes names and detailed descriptions of the anatomy of animals all across the tree of life. He does descriptions of various apes. I think he might have done the first anatomical description of gorillas. He might even have named gorilla, given the scientific name to gorillas. I may be making that up. Apes, giraffes, marsupials, monotremes, many other mammals. He did research on lizards, apparently important early descriptions of lungfish, birds, including the first scientific description of a complete dodo skeleton.
Oh, that's awesome.
He studied invertebrates, including cephalopods like the nautilus, brachiopods, horseshoe crabs, sponges. This guy got around in terms of the animals that he studied. He is also sometimes credited with discovering the parasitic worms that cause trichinosis.
Oh.
Although some sources say that one of his students, James Paget, was the one who made the first report of those.
Gotcha.
Whether or not Owen intentionally took the credit and ended up taking the credit for that, I haven't seen that discussed in detail, but I will say that is a theme that will come up later in this discussion.
Uh-oh.
Along the way, while he's doing all these anatomical studies, he also introduces some really important concepts in the study of comparative anatomy, the most famous of which is the concept of homology. This is something that you've heard us talk about on the podcast a bunch. A homologous structure in comparative anatomy is a structure that you see having a different form and or function in different species, but is derived from the same part of the body.
Yes.
The classic example being limbs, right? Our arms have all the same bones as the wing of a bird or the wing of a bat and the flipper of a whale, and so on. Those are homologous structures. They're built of the same body parts, even though they are doing very different things.
Yes.
This is a concept that Owen introduces and popularizes in the study of comparative anatomy.
Which is pretty awesome.
It's pretty cool. And these days, homology is recognized as a really important aspect of studying common ancestry in species. That the reason that those homologous structures are built from the same stuff is because they inherited them from a common ancestor. Owen notably did not interpret them as evidence of common ancestry, but instead of a shared archetype, basically a blueprint of vertebrate life. I'll talk more about that later, but this does become one of the points of contention between him and contemporaries like Darwin and Huxley.
Okay.
Owen also does a whole bunch of research on fossils. He does tons of anatomical descriptions of especially vertebrate fossils. This, like his study on modern stuff, runs the gamut of all sorts of things. He studies a number of South American mammals, including a bunch that Darwin brought back from his journey of the Beagle.
Cool.
Darwin came back with fossils and brought them to Owen, and Owen identified a bunch, or at least brought them to the museum. So he describes sloths, glyptodonts, the weird hoofed mammals of South America like Toxodon. He also does a number of studies on Australian mammals. He named and described Diprotodon and Thylacoleo. This is why we know his name. He comes up everywhere.
Yep.
He also identified and described the remains of moas from New Zealand, gave them their scientific name, Dinornis. That comes from Owen. And he described the first known skeleton of Archaeopteryx in 1863.
Oh, wow.
He was not the first person to describe Archaeopteryx, and he didn't name Archaeopteryx. It was named a couple years earlier, but the London specimen of Archaeopteryx became the London specimen because it was dug up in Germany, described by a researcher over there, but it belonged to a private owner, and Owen managed to convince that owner to sell it to the London Museum for the price of £700, which I assume in 1860-something dollars is immensely expensive.
Yeah, that sounds like it would be a lot.
And then he was able to do an anatomical description, one of the first descriptions of the skeleton of Archaeopteryx.
Cool.
He also described and named, famously, one trace fossil, Protichnus, the oldest known footprints in the fossil record.
Cool.
These are Cambrian arthropod footprints, which he identified as arthropod footprints.
Cool.
And it was like a century and a half later before we ever found body fossils of what animals may have created those footprints.
That's pretty sweet.
So he did tons of research on both modern and fossil animals from the lens of comparative anatomy and identification. As I alluded to before, there are some stories of him not always giving credit to the people who found and sent him those fossils. There are some particularly famous examples of this where he seems to have been, someone found a fossil, shared it with him, and he publishes it as his own discovery, supposedly.
Mm-hmm.
Like I said, there are going to be some themes running through here. Here's a fun note that I found about him that I thought you would quite enjoy, Will. He was, as I said, somewhat of a celebrity scientist, popular lecturer. He did a lot of work describing the remains of animals from all around the world, including fossil remains, including animals that hadn't been described or understood very much before that. Apparently, according to one source that I read, he was also in the habit of exposing frauds and debunking cryptids.
Yay! Yay! Oh, that's lovely.
So I think it sounds like he would also be called on to be like, yeah, here's this evidence for the existence of some such animal, and he would be the one that goes, yeah, that doesn't make sense here, pointing at whatever anatomical features or whatnot, or picking apart the evidence.
That's makes me very happy.
And of course, in addition to those other fossils, he also did a bunch of work on fossil reptiles. Especially, he did lots of work on British fossil reptiles, that is where he was, including publications on plesiosaurs, ichthyosaurs, crocs, pterosaurs, and more. Late in his life, in the 1880s, he published what one biography that I read of his called his magnum opus, which was a 3-volume set called A History of British Fossil Reptiles, which had detailed descriptions of plesiosaurs, ichthyosaurs, crocs, and all these other fossil reptiles from the region.
Cool.
And this brings us, of course, to what is perhaps his most famous contribution that we mentioned before. In 1842, in a report on British fossil reptiles, he wrote detailed descriptions of 3 particular reptiles that today are quite famous: Megalosaurus, which had been named in 1824 by William Buckland, and Iguanodon and Hylaeosaurus, which had both been named and described by Gideon Mantell. Owen, in this report on British fossil reptiles, described all 3 of these creatures and identified shared features among them, including the hip vertebrae, the sacrum, the hip part of the spine, sharing several fused vertebrae, particular shapes and proportions of shoulder bones, limb bones, vertebrae, the way the ribs attach to the vertebrae. With all of these features in all 3 of these animals, he suggested that they should be classified as one group. This portion of the paper reads thus: the combination of such characters, some, as the sacral ones, altogether peculiar among reptiles, others borrowed, as it were, from groups now distinct from each other, and all manifested by creatures far surpassing in size the largest of existing reptiles, will, it is presumed, be deemed sufficient ground for establishing a distinct tribe or suborder of saurian reptiles, for which I would propose the name of Dinosauria.
Nice.
1842, that paragraph, I think that's a sentence, but it's a paragraph-long sentence, Richard Owen invents the word dinosaur.
Very cool. It's also super interesting to think of him doing this, and not that he was the only one who was doing anatomical studies or comparisons at this time, but just that this was a time where that was still a fairly young, practice and concept of using those kinds of things to group and organize life. Is such a crazy thing to think of, since that's such a staple nowadays of just that's what you do.
Yeah, he was a pioneer in paleontology and even more specifically comparative anatomy.
Yeah,
he is one of the founders, as it is, of comparative anatomy,
which is a very cool thing to be a founder of. That's a big deal.
Well, and especially because of how important it is these days to our understanding of life on Earth. And as we'll get into a little bit later, it's interesting to see how he was interpreting the evidence that he was picking up.
Yeah.
In some ways, it was very much like he is the first person to identify dinosaurs as a united group of animals. He also, very famously, in his studies of dinosaurs, based on the features of their limbs, he interpreted them as being clearly terrestrial on land and standing like mammals did, with their legs directly underneath the body.
Cool.
Or like mammals do, I suppose. This becomes realized in physical form. In the 1850s, he is the scientific director overseeing the creation of the Crystal Palace dinosaurs. This is, so if you're not familiar with the Crystal Palace sculptures, this was a series of 33 sculptures depicting extinct animals of the region. These were designed and created by Benjamin Waterhouse, overseen by the scientific direction of Richard Owen.
Yeah.
These sculptures include ichthyosaurs, plesiosaurs, dicynodonts. Many of these are famously outdated.
Yes.
The ichthyosaurs are basking like seals on the ground. The dicynodonts have like shells on their backs. 3 of those sculptures are dinosaurs. And these were the first ever life-sized models of dinosaurs, and they are extremely outdated in terms of how we understand these animals. They're all quadrupedal, even Megalosaurus and Iguanodon, which were certainly not like that. This is the one where Iguanodon got its thumb spike on the nose like a rhinoceros horn.
Yep.
Megalosaurus has the just big old mouth full of those teeth. They're very lizard-like.
Yes.
In this early depiction of them. But for all of the updates that have come since then, a bunch of stuff about them was quite accurate, including putting the legs directly under the body.
Yeah.
That is something that is a defining feature of dinosaurs.
I had that thought as you said that even though we love to kind of poke fun at the Crystal Palace dinosaurs, and Iguanodon especially, because it's so different than what Iguanodon looks like now in our paleo art, in our reconstructions. But it was standing like a mammal, not with its legs sprawled out to the side like a lizard. So even though it had a lot of lizardy-esque things going on, that was still there. And so there is, even in that early depiction, they were still notably their own thing.
Yeah, they were very unusual and distinctive as dinosaurs are.
Yes.
I absolutely like to come to the defense of the Crystal Palace dinosaurs because they are so often brought up as like, look, paleontologists back then had no idea what they were doing. And in some ways that's a little bit true. It's true in the sense that we had 3 dinosaurs with partial skeletons that defined the group, a decade before that. So it was a very new group of animals for us to understand. But also, that's most of the way to a dinosaur. Like, Megalosaurus is on all fours and Iguanodon's got a little spike on its nose. But they're reptiles with the legs under their bodies. All the pieces of the body are more or less where they're supposed to be on the body. Like, it's a pretty astounding feat.
Yes.
To have recreated these animals, and the updates to them have been visually very distinctive, and in terms of our understanding of how they behave, very important, but mostly postural differences.
Yeah.
They did a pretty darn good job with the Crystal Palace sculptures for 1850 whatever.
Well, it also, for me, falls into the category of you have to start somewhere.
Yes.
Like, and very rarely is the starting point in these kinds of things almost dead on correct. That's just kind of the nature of things. So yes, those are comically inaccurate to our nowadays understandings. And if you've grown up with modern dinosaur books and you look at that, they look like cartoon characters.
Yes.
But that we had to start somewhere, and those helped us get here.
Yes.
So it was critical, kind of, that we put our first ideas to form so that we could build off of them.
Yeah, and also those really help to drum up public interest.
Yes!
Which I'll get to in just a second. Before I get to public interest, I do have to mention, this is one of the famous stories about the Crystal Palace dinosaurs, that on New Year's Eve of 1853, Richard Owen famously hosted a dinner for prominent scientists inside the Iguanodon sculpture. They had like tables set up, because this was like a giant concrete sculpture. And it was hollow, so they set up inside of it, and he hosted a little New Year's Eve dinner. And I'm sure you've seen also the illustrations of this, of him like raising a glass to all of his buddies in the Iguanodon.
I had a book that had that illustration in it, and as a kid I had one of those, like, because so many of your books as kids have those, metaphorical or analogy images to be like, it's like this,
Right.
And I wasn't always reading the words in my books. I was just looking at the pictures. So half the time I'm like, I'm going to assume that's one of those pictures because that doesn't actually make sense to be in this. And that's kind of how I felt about that until I learned about it later. Is like, oh, that was legit.
That's a thing that actually happened.
That actually happened. That wasn't just like, and then they celebrated and Iguanodon was a big deal, so we made it into a table. It's like, no, actually put a table in it. Okay.
Yep.
Fair enough. Weird, but great.
I mean, I guess if you're the celebrity scientist... Look, he didn't start off wealthy.
Yes.
He grew into being extremely famous and well off.
If I had a giant concrete Iguanodon, I'd have dinners inside
Absolutely.
it.
Yeah, for
we
sure.
put a chimney in it and we'd cook in there.
In 1856, Owen becomes the superintendent of the Natural History Department of the British Museum. This was a museum that had a bunch of different departments for different museum-type stuff. In this position, in addition to giving lectures and doing lots of research, one of Owen's major goals became getting the Natural History Department of the British Museum its own space. Oh. He dreamed of moving the Natural History Department to a new location so that there would be more space for the collections, but also so that they could put things on display. Now, remember, we've mentioned this before on the podcast. For a long time, that wasn't a thing that museums were really popular for doing. Nowadays, we think, yeah, you go to a museum, there's bones on display.
Yes.
But in the mid to late 1800s, and here in North America, really in the early 1900s, that was a new sort of thing. I think I mentioned in the Bone Wars episode that, like, Marsh didn't like the idea.
Mm-hmm.
There were paleontologists earlier on who were like, why are you going to put these bones on display? That's what's the point of that? Leave them where we can research them. Owen wanted to be able to put incredible specimens on display for people to see them. He succeeded in 1881 in getting the collections and displays of the Natural History Department moved to a new facility in London, which became the Natural History Museum.
Pretty good.
We have referenced this museum on the podcast countless times. This is the Natural History Museum in London. It is one of the most famous and important museums of natural history in the world today.
Not a bad entry on your resume.
Put that on a CV.
Yeah.
It's like, also, I founded the London Museum of Natural History.
Yeah, capital T,
and this is, I've mentioned this before, that natural history museums often get abbreviations. The one in New York is the AM&H, the American Museum of Natural History. The Field Museum is the FM&H. The LACM, the Los Angeles County Museum. It has always struck me as impressive that the London Museum is the NHM.
Yes.
The Natural History Museum.
Yep.
That it's the one. This museum opened on Easter Monday in 1881 to around 16,000 visitors, which is an impressive number of visitors to get at your cool new museum.
That's a pretty good turnout.
I saw one description of Owen point out that he was instrumental in transforming our expectations of what museums are.
Yeah.
Like these days, the idea of a museum as a place for public education and engagement started with initiatives like this.
That's pretty monumental. Like it's a very alien concept to think that that's not what museums always were. Mm-hmm. But thank goodness they are now, and thank goodness they became that.
Yeah. Nowadays, they're one of the most prominent sources of education and information for people.
Yes, absolutely.
And I know I've seen it referenced in a number of places that museums are consistently ranked as one of the most trusted sources of science information, at least in this country, and I assume other countries.
Yes.
Owen helped to do that, which is a good thing to keep in mind for all the stuff we're going to say about him later. In 1883, Richard Owen becomes Sir Richard Owen. He is made a Knight of the Order of the Bath. I did look up, I assume that I don't know anything about British like royalty or chivalry. The Order of the Bath is a British order of chivalry. I did a little bit of Googling about it, and I think it goes back to like true knights.
Yes.
And some sort of ceremony that had to do with bathing. I don't know if like the king was taking a bath or something, but it was an important... So yes, Richard Owen became a Knight of the Order of the Bath.
Take a bath inside the iguanodon.
Inside the iguanodon. And he becomes Sir Richard Owen for about a decade. Owen continued to publish basically his entire life. He was one of those scientists who started in the 1820s when he was, 20 years old or whatever, and then just published papers until he couldn't publish papers anymore.
Yep.
Over the course of his life, he published hundreds of scientific studies.
Ridiculous.
He named tons of familiar modern and ancient animals. He had a monumental volume of scientific work before finally dying at home in December of 1892, shortly before the end of the century. On the tail end of over in North America, the Bone Wars are coming to an end at that time. People are still arguing about Darwin, and it would still be a couple decades before Owen wanted space in the museum for big whale skeletons to go on display.
Yeah.
It sounded like, and it didn't happen until a couple decades after he died.
All right.
It happened.
It
did eventually happen. He didn't get to see it.
Pretty cool.
So Owen, for sure, contributed a bunch of important things to our favorite realms of science. He is also remembered as quite a controversial figure.
A little bit.
And we're going to talk about the reasons for his controversial figureness After the break, we will start with Owen's personal feelings about evolution and his interactions with Charles Darwin. Stay tuned. Richard Owen's time as a prominent scientist spans the early years of our understanding of paleontology coming into what we would recognize now as a field of science of its own. This is also the time period where our understanding of evolution is coming together. In the early years of Owen's life is the time that early theorizers of evolution are coming up with ideas and starting to put the evidence together. Owen was born, like I said, 5 years before Darwin. So as Owen is coming up and developing his own theories about animals and anatomy, so too is Darwin, going on journeys around the world in his boat and doing experiments at home and working on his grand book. We talked about this in episode 28 on Charles Darwin. We also talked a bunch about this stuff in episode 56 in the evolution of evolutionary theory. Richard Owen is often depicted, as I mentioned before, as a villain in the story of the discovery of evolution, as a rival to Darwin. Owen is often claimed as having been anti-evolution.
Yes.
Which is not true.
Yes.
Owen was not anti-evolution. He did disagree with Darwin, but he did not entirely dismiss the idea of evolution. In fact, at one point, apparently, he was quoted as saying that Darwin's explanation was the best published, but that he disagreed with some of it. And at another point, it sounds like Darwin had listed a bunch of prominent scientists who were defenders of immutability, right? Immutability, the idea that species don't change over time. And he put Owen on that list, and Owen got mad at him for it. Owen was like, no, I don't belong on that list. Owen was certainly not anti-evolution. He disagreed with Darwin. He had his own sort of ideas. It also sounds like his perspective may have varied in private versus in public.
Okay.
There are reports of him supposedly wrote an anonymous article harshly criticizing Darwin, but he didn't publish it under his name. He wrote it anonymously. So what his feelings were over time seemed like they may have been hard to pin down, or at least he was saying a variety of things. Owen's claim to fame concept in relation to understanding the relationships of animals on Earth was the idea of a vertebrate archetype.
Mm-hmm.
So he, like I said before, he described the concept of homologies, and in doing his expansive study on animals from all around the world, he looked at skeletons and body plans and found that there's a lot in common between birds and reptiles and mammals and fish, suggesting a commonality.
Yes.
Darwin's ideas would interpret this as evidence of common ancestry, right? Those limb bones are the same because ancestrally they started out in a certain way and then that got modified in different lineages.
Yeah, because they came from the same thing.
Came from the same original ancestral state. Owen interpreted it as more of a blueprint, the idea that all vertebrate animals were created off of the same blueprint.
Okay.
And this is an idea that is explicitly, in some of its descriptions, tied to the idea of a supernatural creation.
Yes.
That he felt, at least in some of his writings it seems, that in studying anatomy and finding these similarities, he was uncovering the blueprint of the divine mind.
Yes.
These are the parts that are used to make a vertebrate, and then they are modified to fit different environments. Exactly what processes modified things? He did, it sounds like, write about various natural forces that might be causing these changes. He entertained thoughts like Lamarck's ideas about change. He wrote a bunch about parthenogenesis and just asexual reproduction of species, but he did not agree with Darwin's notion of a deep time common ancestry driven by natural selection. In one of his studies, he even comes up with this notion of sort of like, he calls it archetypus, which is, here is a hypothetical basic archetype. Like if we take all the pieces, all these homologies across vertebrates, and we distill them down to their simplest version, here is like the simplest version of the vertebrate archetype. And other researchers have since pointed at it and noted that it looks a lot like a lungfish.
Yep.
Which is very amusing because these days we know that lungfish is a pretty good representation of the ancestral state of land vertebrates.
It's almost comically intriguing how differently he was interpreting the same evidence.
Mm-hmm.
And you can follow his logic. Like,
absolutely.
The logical thread is definitely there, so much so that he came up with a hypothetical, not ancestor in his words,
right,
but vertebrate.
Yeah, exactly.
And it followed the same logic that we would have used to come up with a hypothetical ancestral state.
Yes.
For vertebrates. And that's very, he was using the same science and evidence, but just caught on a couple of things that led him to very different interpretations.
And it's worth noting that at this time, Darwin was also wrong about a bunch of stuff in his interpretation. The ancestry happens to be a thing that Darwin wasn't wrong about and was upheld by further studies, while Owen's idea was not, and therefore got discarded and isn't an idea that is upheld by the evidence. I've seen it pointed out a number of times, the irony that Owen wasn't a proponent of natural selection and argued against a lot of Darwin's ideas, but was also the person who provided some of the strongest evidence that would end up supporting Darwin's theories of natural selection.
Yeah.
That, like, Owen was the person who popularized the idea of look at all these common features across vertebrates, and then Darwin and other evolutionary scientists would look at that and go, yeah, common descent, that common ancestry, you did it. You found the incredible evidence. And Owen was like, no, that's not what that means. It means this other thing.
Yes.
Which wasn't of it. So he was instrumental in setting the foundations for evolutionary science, even though he himself disagreed with many of the main points that would later go on to become established parts of it.
And I appreciate you making the point of, like, that Darwin was not just 100% correct.
Mm-hmm.
And even though we now know that Owen was mostly wrong in the assumptions he was making.
His major sort of the direction he was mostly pointing in turned out to be incorrect.
Yes. But, and it, very much like the Crystal Palace dinosaurs, it's so easy to look back now and go, whew, you were so off base, man. Right. If you had just listened up, maybe
if you just listened to the smart guy in the room. Well, we've talked about the same thing with Lamarck.
Yes.
That Lamarck has this reputation of being the idiot who came up with the giraffe thing.
Yep.
But, like, no, he was a foundational key part of early theories about relationships between life on Earth.
Well, and it's the thing it's very important to remember back then is, like, how was he supposed to know any better? How was Lamarck supposed to know any better?
He was working with the evidence he had.
Yeah, and he came up with an idea. It made sense with the assumptions he had to put in place due to lack of evidence and lack of understanding.
Mm-hmm.
Same with Owen, that at that time, what they didn't have books to go, well, let's go check the internet.
Right.
Like, this was the formation of these ideas. So it seems ridiculous that there was an opponent to Darwin at the time. For us now...
Well, and especially... And this is part of why Owen ends up getting cast as this anti-evolution person. Because from our modern perspective, we hear he disagreed with Darwin, and we assume that, obviously he thought that evolution was nonsense and favored... he must have been strongly religious or whatever. But this was a time where there were several major competing hypotheses for how life changed over time, how life was interrelated.
It's
really interesting.
Yeah, like from a historical perspective, I feel like this is a very important bit to just be reminded of, that just because they ended up being wrong doesn't mean at the time they were being ridiculous.
Right. Now, Owen was being ridiculous for other reasons.
Yes, indeed.
And a thing that I've seen noted in some places is that over the course of his life, he remained very staunchly in favor of his own hypotheses while the evidence continued to mount for Darwin's version of this theory. So Owen kind of, it sounds like, may have fallen more and more out of favor.
Yeah.
By the later years of his life, his ideas felt more outdated.
Which is...
He was falling behind the times.
Yeah, which is a surprisingly common thing to happen. Like that, there's tons of researchers where, as they get later in life, these sorts of things are noted where they plant their feet on one idea and then they kind of get left behind because the evidence no longer supports them. And since they are no longer acknowledging the evidence, the scientific community just kind of moves on without them.
And it sounds like something like that happened with Owen as well.
Yeah.
Another place where Owen got into conflict with his other evolutionary peers is Owen was a strong proponent of the idea that humans are distinct from other animals. That humans are unique and separate and not part of the same... these days we'd think of it as the evolutionary tree of life, but that something is special about humans that distinctly separates them from all other animals.
Yes.
The most famous, it sounds like, manifestation of this is what has become called the Great Hippocampus Question, which was a famous argument between Owen and Thomas Huxley, who was a student? I don't remember if Huxley was a literal student of Darwin or a figurative student of Darwin. But he was Darwin's buddy, and he supported Darwin, and he did a lot of public arguing and such. Owen had made a very famous claim that there is a part of the brain, which he called the hippocampus minor, which has a different name these days, and I didn't write down what it is. That this part of the brain, he argued, was unique to humans and was the source of the unique features of human that clearly draws a line. Humans are special, not the same as everything else. Huxley showed, correctly, that this is not true. That the other apes also have that part of the brain. They would do like dissections and show off the brain anatomy. This became a very public debate between them, arguing back and forth, and it became central to the question of human evolution, which of course was also big on the minds of scientists and the public at the time. And this was one of the reasons why Darwin took so much heat. That Darwin said, humans are also part of this evolutionary process. And a lot of people went, no, now you've crossed a line.
Yes.
It's one thing that I read, it made it sound like an early publication that Owen wrote also hinted at the idea that humans may be related to other animals in a similar way, and he got heat for it.
Interesting.
This debate, the hippocampus, the human and ape brain debate, became so popular that it was satirized in a children's book by Charles Kingsley, who called it the Great Hippopotamus Test.
Nice.
So he was, Owen, not anti-evolution, but did a lot of arguing with both Huxley and Darwin about the details of evolution, and he turned out to be wrong about a bunch of important stuff.
Yeah. And it sounds like there might have been some, and this is probably a hard thing to really confirm from a historical perspective, but the fact that he, felt like he was uncovering the pattern of the divine.
Yeah.
And the fact that there was this sense that humans were separate goes very in line with the fact that we are described as being made in the divine's image.
Absolutely.
So I could very much see that Owen might have just been derailed by some core beliefs that he had separate from science that drew his conclusions off course, which happened tons of times back in the day.
Oh, sure.
During the early days of us figuring this stuff out. But yeah, no.
Well, and even if he wasn't like a deeply religious figure, I honestly don't know. I didn't see that come up anywhere. In my surface levels, I'm sure there's more written about Owen. But even if he himself wasn't deeply religious, those were very entrenched ideas in society.
Yes.
And so it's very easy to get stuck on those assumptions, those interpretations of the world. and try to fit new evidence into that pre-existing system.
Yeah, which once again, not to defend just gratuitously, but it's very easy to look back and go, oh, silly, silly person from the past.
Right.
How did you not know
How
better?
How silly of you.
I always like to have the perspective of, in 200 years, people are going to look back at us and go, wow, I can't believe that idea was so pervasive that it made them that wrong about all of these things. Like, they're going to say that about us. So it is something that just all societies have to struggle with, that we have ideas that we don't really think about, that we do think about all the time.
Yes. Now, that's not to say that evolutionary science is going to be wholly overturned. No. That's a thing that I think often gets lost in these discussions, that we look back at people in the past and it's easy to go, oh, well, they were wrong about stuff and someday in the future we'll also be wrong about everything. They weren't wrong about everything.
No.
In fact, they were right about most things back then, just as we are today right about most things and more than what they were right about. But there's tons of stuff in the fringes of our understanding, new things that we're still trying to figure out what they are, that in another century or two will be no longer arguable.
Yes.
Right, like 100 years from now, you know, there may be scientists who are like, can you imagine what it was like when they didn't know that all early reptiles had feathers?
Yeah, or
like, nowadays we know exactly where feathers came from. We have all that evidence. Back then they had to argue about it.
Yeah, man, it must have been exhausting when they had to discuss what the origin of life is. We know it now.
Right, that kind of stuff. The stuff where we don't have the mountains of evidence yet.
Yes, and in my example, I wasn't even just meaning evolutionary theory. It's just societally and as humans.
Well, also that.
Yeah, like
there's Owen, I'm sure, was also wrong about a bunch of non-science opinions that he had.
That is just like, as when you have this much of a gap in societies, it's very easy to see what was normal for them as very weird.
Yes. Now, while we're defending Owen, this is a great time for me to bring up that one of the other things that is most famous and oft cited about Richard Owen is that he was just an absolute piece of work.
Yeah.
Owen is described in very poor terms very commonly.
Yep, yeah. My defenses are definitely in the thinking at the time.
Absolutely.
Not so much the human at the time.
How defendable Owen is an open question. Owen is often described as vain, arrogant, and spiteful. He is accused of stealing specimens and not crediting others.
Ooh, that's a bad one.
One famous example, he supposedly left out crediting Gideon Mantell with the discovery of Iguanodon. He was accused of writing anonymous criticisms of his colleagues. He is rumored to have written an anonymous obituary of Gideon Mantell that was like a mean obituary of him.
Oh.
And I didn't read much detail about this, but apparently he was eventually dismissed from the Royal Society's Zoological Council for plagiarism. Here are some things that people said about Owen. One biographer called him, quote, a social experimenter with a penchant for sadism. Gideon Mantell, the guy who described Iguanodon, who was a contemporary of Owen who worked alongside him, said he was, quote, overpaid, overpraised, and cursed with a jealous, monopolizing spirit.
Oh.
Owen Mantell also said that it was, quote, a pity a man so talented should be so dastardly and envious. People had strong words about this guy. Darwin suggested multiple times that he and Owen became rivals not because of any personal reasons, but because Owen was jealous of him.
Yeah.
Darwin himself accused Owen of just being jealous that Darwin was the famous one. Darwin also said, quote, no one fact tells so strongly against Owen as that he has never reared one pupil or follower. I love that every now and then we get to go back into these historical accounts and read just the cattiness of early scientists.
Wow. That's so mean.
It's so easy to get so caught up in the science, the legendary scientific status of Darwin and Huxley and Owen, and forget that they were also mean girls.
Yep.
So the people who knew Owen didn't like Owen. They had a lot of mean things to say about him. Now, some, especially more modern scholars, have suggested that his villainous reputation may be somewhat undeserved. They've pointed out that that reputation may have been encouraged by certain colleagues. Like the fact that Darwin and Huxley were saying these things about him, especially later in his career, may have sort of built up more of this reputation for him.
Yes.
Than perhaps was deserved. He also gets cast as a villain, like we were saying, because he was wrong about stuff. He's stuck with arguing against Darwin, even as Darwin's theories became more accepted. He claimed very strongly that humans were separate from other animals. I think at one point he even classified humans separately.
Oh, weird.
From mammals and whatnot. So he had a bunch of ideas that aged poorly during and after his lifetime. So he's built up a bit of a villainous reputation. Perhaps some have suggested more than is deserved. But also, a lot of people who worked with this guy seem to have not enjoyed working with this guy.
Well, and there's a lot of not just slanderous quotes, but a lot of accusations of just wrongdoing.
Mm-hmm.
That it's like, even if only half of those are true, that's not good.
Right. That's still a lot.
Yeah, some of those are immediate blacklist things in today's paleontological society.
If you got kicked out for plagiarism
or stealing specimens.
Well, they should be immediate blacklist things.
Yeah. But nowadays those are extremely taboo.
Well, and also back then they were extremely taboo. This was a celebrity person.
Yes.
Which some things don't change about our field of science.
Yep.
But yeah, this guy was accused of being unethical and rude and just bad. Just a bad guy.
Yeah.
Which complicates the question of his legacy, which tends to end up being a theme in these episodes where we talk about historical figures, where we talk about, yes, Darwin did a lot of great things, also said some just truly racist stuff.
Oh, yeah.
And had, built some of his hypotheses on racist ideologies. Nopcha, who we talked about in 106, did a bunch of great work, also truly a troubled person, right up to the tragic ending. Owen is renowned for some really important stuff that he did. He was a key figure in early studies of anatomy and paleontology. He founded the Natural History Museum in London, which is an incredibly influential institution. He was a public figure who helped promote appreciation and understanding of biology and of paleontology. Even Huxley, who argued a bunch with him, had said after his death that a lot of his ideas were wrong, but he did a lot of important and excellent work in the field.
Yes.
So he did a ton of really important stuff. Also was apparently not a nice person.
Yep.
Richard Broke Freeman, a zoologist in the early 1900s, called him, quote, the most distinguished vertebrate zoologist and paleontologist, but a most deceitful and odious man.
Yeah. Yeah. And it's a lesson that, as you said, we return to often, and it is a very important one, that noting these figures is important and critical to put things in context. The history of our understanding of these things in context. You can't, go over that topic without learning about these people. But by and large, most of them should not be hero worshipped.
Right. And I often would argue no scientist or individual person should be put up on a pedestal like that.
And that's the thing, that it's so easy to do.
Yes. Well, especially the way that we talk about science.
Mm-hmm.
We love to portray major scientific discoveries as though one person did it, working in his basement, in his cabin, on his boat, made all these incredible discoveries and handed them to the world on a golden platter, and everybody bowed down and said, congratulations, you changed science forever.
Yes.
Which is not ever how that works.
Well, and I think it also, very often we make the mistake of thinking, okay, but without Owen, we wouldn't have dinosaurs. No, someone...
Right. They wouldn't be called dinosaurs.
They would have almost certainly had a different name.
He named them that.
but someone would have noticed that as well.
Oh, sure. He didn't invent dinosaurs.
Yes.
He discovered the relationship of dinosaurs.
And so I think that, like, that mentality is very easy to get stuck into of, like, but without him we wouldn't have that. We probably would.
Right. Well, and it's also very possible to be grateful and appreciative of the work that somebody did, and even admire the work that somebody did, while also recognizing that there are aspects of that person. You should not aspire to be Richard Owen.
Yes.
You might aspire to do diligent work the way that he did, or to make detailed descriptions, or excellent insights into the connections between animal life around the world, like Owen did. But you should not aspire to be like Richard Owen. You can sort of pick out what parts are good and admirable while still acknowledging that there were things about him that weren't things you should be emulating.
Yeah, I think a lot of times historical figures get grouped and discussed in similar ways as we do with fictional characters. Like heroes.
Well, because they become the characters of stories.
Exactly, because that's what history is us telling the stories of those people. And Spider-Man was made to be a person you can emulate and look up to.
We can slander the Green Goblin
Yes.
all we want.
Yes.
We can say that he is terrible. We can cast him as a villain. He is. That's the point of that person.
That's his job.
And we can worship Spider-Man as a hero. That's the point of Spider-Man.
That's what they were created to do.
These are real people.
These are real people. They had just as many flaws as any one of us. Some more, some less, depending on what flaw you're looking at.
Sure.
They were just humans.
And it can be very difficult to separate. If someone says, wow, Owen was a great scientist, it can be very difficult to not receive that as that person ignoring all the bad stuff. And simultaneously, it can be very difficult to hear somebody say, wow, Darwin was really problematic, and then feel defensive and go, oh, but you can't just ignore all the good stuff. You have to do both.
Yes.
And we have to, which is why in these episodes, I like to make it a point to say, here's all the great stuff this person did. Here's some of the nasty things that apparently they were also like back then when they were alive. Because like you said, it also puts important context, right? The fact that this person who established so many foundational concepts in biology disagreed with Darwin's interpretations of evolution, that's important for understanding the work that he did. Right. The fact that one of his sort of a counterpart of Owen over here in North America, Henry Fairfield Osborn, who did very similarly, was a champion of, founded the Natural History Museum in New York and was a champion of public appreciation of dinosaurs and just did a ton of research and described a bunch of animals and stuff. Did a bunch of great work. Also, eugenicist.
Yep.
That's important. That is important for understanding his body of work.
Well, it's kind of how we've talked about one of the critical aspects of paleontology is you can't actually make sense of life on Earth the way it is now without understanding how it has been. You know, you can't see the full picture of life now without understanding how it got to this, the steps it went through to get to this. The same could be said of scientific community and systems.
Oh, sure.
That if we just ignore the history that made paleontology what it is today, we would be ignoring some things that might be very important for us to fully understand and uncover and go, maybe that's why that's still such a problem. Or maybe this is where we got started on this thing being an issue and we can finally undo it.
So shout out to all the people listening who are either historians or minorities.
Yes.
Who are saying, yeah, duh. Hopefully that's what you're saying and agreeing with the points that we're making. So yeah, it's important to acknowledge these sort of stumbling blocks in the past.
Absolutely.
One thing that I thought was really interesting, I didn't go into like a super deep dive on this, but I did find 2 biographies of Owen that were written shortly after he died. There was one that was a biography. It was like a series of biographies of like eminent people that was written in the late 1800s. And then there was a biography of him written by his grandson, who was also named Richard Owen, as was Richard Owen's father. He came from a long line of Richard Owens. So his grandson wrote this other obituary, not an obituary, but a posthumous biography, I think in the later 1800s. Both of them went over like his significant work in the field. Neither of them mentioned dinosaurs.
Interesting.
Which I thought was really interesting, that today that's a thing that we associate. Yeah, he came up with the word dinosaur.
Yes.
But the biographies of him that celebrated his scientific work shortly after his death didn't mention that.
Yeah.
And I suspect that it's a combination, and it's very possible that he was known for that and I just didn't come across I didn't do a super deep dive. But I would suspect, if that's true, it is a combination of, number one, he was fresh in the minds of people for all this other stuff that he did, all this other impressive stuff.
Yes.
And also, dinosaurs weren't that big a deal at that time.
Exactly.
Right? This is before dinosaurs became dinosaurs. And they became dinosaurs in part because we made a bunch more discoveries, especially in the rest of the 1800s. But then also movies happened and museums happened more frequently, and dinosaurs entered the public consciousness. And it isn't until way later that anybody even cares who came up with the word dinosaur. Like these days, we don't care who came up with the word mammal.
Yep.
Like it's not, I don't know who, Linnaeus, I assume. I don't know. Like that's not, but dinosaurs are a phenomenon among people. So nowadays we look back and go, oh yeah, that guy did that.
Yes.
But the people at his time, I don't want to say they didn't care about it, but it sounds like they didn't particularly care about it at that time.
That was just another thing he did.
Yeah, one of many names that he came up with.
Very cool.
So, Sir Richard Owen, a very important, prominent figure in the early history of paleontology, a contentious figure,
yes,
sometimes controversial figure, often misrepresented in the way that he is spoken about. Perhaps underappreciated. There are a number of pages on the Natural History Museum website that called him underappreciated.
Yeah.
They're like, yeah, this is the guy who founded our museum. Here's a bunch of cool stuff that he did that you may not have heard about because he's not Darwin. He's not one of those big enduring names.
Very interesting combination of achievements and as compared to his reputation and like very interesting.
As always, listeners, if you'd like to learn more about this historic figure, we'll have a blog post on our website after this episode that you can check out. There'll be links there that you can follow if you'd like to read more. Before we wrap everything up, there is one last thing to do as our discussion winds down, and that is a patron question. Every episode, we like to answer a question submitted by one of our patrons. I have selected an appropriate question that is also a historical related question about dinosaurs that ties in quite nicely. Will, please tell us this episode's patron question.
This episode's question is from Leo, who says, you mentioned a few times that the scientific community made an exception to the rules to keep the name Tyrannosaurus rex. I read that according to those rules, the first ever scientifically described dinosaur, Megalosaurus bucklandi, should be named Scrotum humanum, and that there were some efforts to rename Dinosauria to Scrotalia. What do you know about this story, and how do you like the name Megalosaurus, considering the alternative?
Thanks, Leo, for that great question. We have managed to go 180 plus episodes of this podcast without ever, I think, diving into the story of scrotum.
Yeah.
So while we're talking about historical events in the study of dinosaurs, let's talk about the scrotum story. So first and foremost, a note about naming priority. We have mentioned before, like Leo said, that Tyrannosaurus is sort of an exception to the rule because there were fragments of vertebrae described and named as mammoth that later turned out to be Tyrannosaurus, and Tyrannosaurus was named later, so by the rules of priority, mammoth is the name that came first, and so should supersede Tyrannosaurus, but it was decided that it doesn't supersede Tyrannosaurus, and Tyrannosaurus sticks around.
Nothing supersedes
Nothing supersedes. And we have sort of offhandedly called this that we bent to the rules, we made an exception to the rules. Technically speaking, no one changed any rules. We make the rules.
Yes.
And there is precedent for this. So mammoth is not the only example that something like this has happened for. There are plenty of other examples where it has been officially decided to classify the first name as not a valid name for a number of reasons. In the case of mammoth, a number of authors have pointed out that the fragments of vertebrae that it was named on aren't enough to give a name to.
Yes.
They're not enough to say for sure what dinosaur that is, which would make mammoth arguably a dubious name, a nomen dubium. It's a name without actually enough identifying features to say what this is.
Yeah.
So it doesn't count. The argument through the ICZN, the International Commission of Zoological Nomenclature, the, quote, exception to the rule is akin to what is called a nomen oblitum, or a forgotten name. The argument being that the name mammoth was technically given to some bones, but then basically never used.
Yes.
And Tyrannosaurus was used extensively, so it was it could be I don't actually know what the official ruling comes down on, but it could be classified as mammoth is a forgotten name, and Tyrannosaurus is the name that takes precedent. So it isn't just about what name came first.
It wasn't just a popularity contest in this case as well. Yeah.
So it's not there weren't bent rules necessarily, although again, we make the rules, we do whatever we want. I lay that out not only for clarity, but because that is all relevant to the story that I am now going to tell you. Ahem. One of the most famous stories of taxonomy in the history of the field. In 1677, Robert Plot published a book called Natural History of Oxfordshire. It included descriptions and illustrations of lots of interesting objects, minerals and rocks and bones and stuff, including the illustration of a portion of a femur. It is the lower piece, the part of the femur that articulates with the knee. It is quite large. It is described in the book correctly as a part of a femur, although they identify it as being, and from something giant, they suggest in the book that it might be from a giant human, which was not an uncommon way to interpret giant bones back then. It is a picture of a distal femur. If you saw this picture of this portion, this illustration of this lower part of the femur, you would do a little double take because it looks suggestive.
Yes.
And you wouldn't be alone. A century later, in 1763, Richard Brooks's book, A New and Accurate System of Natural History, includes a number of images and descriptions pulled from Plot's earlier book, including this illustration of this portion of leg bone. Same illustration, also the description is in there in the book that describes it as a femur. But for some reason, the illustration is labeled with the words scrotum humanum, which is Latin for human scrotum.
Yes.
Because that is absolutely, it's the spitting image.
Yep.
It is easy to see why someone would link those concepts, but it is not clear why it's labeled that.
Mm-hmm.
Some have suggested that it was meant as a name for the bone, just named off of the shape. Some have suggested it was just meant to be a descriptor, that just a physical description. A lot of the illustrations have physical descriptions. Others have pointed out that it could also just be a mistake.
Yep.
That whoever was in charge of labeling the images made an error. Regardless, distal piece of a femur labeled scrotum humanum. To my knowledge, I don't actually know how often this was then cited throughout history. I don't get the impression that it was referenced very much after that.
Yep.
But way, way later, paleontologists would identify that bone from the illustration as likely being part of the femur of Megalosaurus.
Mm-hmm.
Megalosaurus was named in 1824. Megalosaurus is famously the first dinosaur to have received a scientific name. Now, because the words scrotum humanum are written in Latin and is two words in the structure of a binomial scientific name, some have suggested that that was meant to be a name, and if it was, and if that bone is Megalosaurus, that would technically make the name scrotum humanum the first name ever given to a dinosaur.
Yes.
This was notably argued in 1970 by a paleontologist named Beverly Halstead, who published a paper arguing that it should be considered a valid binomial name. It's published after Linnaeus introduced the concept, and therefore it is the oldest known scientific name given to a non-bird dinosaur. Others have since taken that one step further and said, doesn't that mean that that name came before Megalosaurus and therefore should have priority, and Megalosaurus bucklandi should actually be called Scrotum humanum? Now, this part is important. To my knowledge, no paleontologist has ever actually suggested that the name Scrotum humanum should have priority over Megalosaurus.
Yeah.
It sounds like Halstead didn't even suggest that.
Yeah. Was just saying it was meant to be a name.
Heck, this seems to be a scientific name. There has been a bunch of back and forth over this name, or if we should classify it as anything. If we were to classify it, there's a number of different reasons why it wouldn't be a valid scientific name. Halstead, it sounds like they argued for it being a forgotten name,
yes.
Much like we talked about with Mammoth. It wasn't used very much, and Megalosaurus has since been used a lot. Others have argued that it could be considered what is called a nomen nudum, a naked name, and the reason for this is the rules of giving a scientific name aren't just that you give a name, you also have to describe what are the features you're using to distinguish this from all other named things.
Yes.
To justify giving it its own name. This doesn't have that.
Yeah. You can't just say, I've named this. You have to say why it deserved to get its own name.
Yes. This did not have that, so it could be considered a naked name because it lacks a proper description. Others have pointed out that it could simply be considered a nomen dubium, because that portion of femur isn't actually enough for us to say confidently that that's Megalosaurus.
Yeah,
There's been some back and forth. This doesn't really have the diagnostic features that we would use to say that is Megalosaurus.
If someone found that piece of that bone nowadays and tried to publish a new species off of it, cousin to Megalosaurus, we would go, no.
Right.
That's... find more of those, and then you can make a description. We won't accept a species definition off of just that chunk.
Right. Also, indeed, this bone, nobody knows where it is. It is a lost specimen, so we can't even go and study it.
And confirm that it was indeed.
Yes. So it could also be considered a nomen dubium, because it is dubiously named. And then there is the other point that has been made by a number of scientists, which is that this whole argument is silly and it doesn't even matter.
Yeah.
Because it probably wasn't meant to be a name in the first place.
Mm-hmm.
That it's very likely that this was just a description or even a mistake. Just because it looks like a scientific name doesn't mean it was meant to be a scientific name. And even if it was meant to be a scientific name, there are many different reasons why it would easily be considered invalid or not a name that we would stick with. I've seen, I think Darren Naish wrote a blog post at one point where he said he's not even convinced that Halstead was being serious when publishing the thing that argued that it should be considered the first ever dinosaur name. And I believe there was at one point a formal request to the ICZN to give this bone, this name, some sort of designation so that we can dismiss it and protect Megalosaurus. Like, make it official that this name will never end up superseding Megalosaurus. And the ICZN's response was basically, we would do that if we thought that that was a serious threat of ever happening.
Yeah.
So, no. Yes, the words scrotum humanum were put alongside this bone. It's never actually been considered seriously that this name might supersede Megalosaurus. The other thing about Dinosauria being replaced with Scrotalia, I've never heard that before. That sounds made up to me. I don't know where that came from.
Yeah.
That's also not how that would work.
Yeah. Like there's no reason.
Dinosauria isn't named after a genus.
Mm-hmm.
It's not Megalosauria.
Yes.
So that wouldn't change anything, even if this name did end up sticking around.
Exactly. Yeah, it very much feels like a situation of, if you have to make so many arguments to just conclude that it was indeed supposed to be a name, feels like already that's too much. They did not do a good job naming it if it was meant to be a name.
Right.
No matter which way you look at it, if we have to do this much debating.
So this is it's a very famous story in paleontology. So is Scrotum humanum technically the first name ever given to a dinosaur fossil? Maybe.
Yeah.
Arguably not. Maybe. Is Megalosaurus in danger of being replaced by the name Scrotum? Absolutely not.
Nope.
Is this story hilarious and fantastic? Yes,
Yep.
100%. Will paleontologists ever stop sharing this story? I certainly hope not. It's great. It's a fantastic story. It's utterly hilarious. I get the very distinct impression that if he had given this bone a boring name, we wouldn't even be talking about it.
Yeah, absolutely.
Only reason we're talking about this is because he called it scrotum and because the illustration looks like a human scrotum. And that is very funny, but that's not actually a serious issue for paleontologists taxonomically.
I wonder if that adjusted the way people would draw that section of a femur from there on out.
Let's just draw it from the other direction.
45 degrees. Put it at a 45-degree angle.
Well, and the illustration it's uncanny.
Mm-hmm.
It's like they were trying.
Yep.
Apparently, at least one scientist later on did take it seriously and described it with in respect to the anatomy of a scrotum. Talks about here is a description of this as a scrotum. It's in the book that it's a femur.
What?
You have gone way too far with this.
Weird.
So yes, there is a famous. Google it. Turn on Safe Search or whatever if you have to. But if you Google scrotum humanum, you will get the story of this dinosaur bone that was given a very silly name.
Yep.
But Megalosaurus is here to stay. It's not going to go anywhere. That's not a concern.
Thank goodness, because Megalosaurus is a good name.
Well, and I've also seen it in many discussions of this name. Paleontologists say, here are a number of reasons why this name would not take priority over Megalosaurus, why it is not a valid name. And thank goodness.
Yeah. Because Megalosaurus is like a Digimon name.
Megalosaurus is a great name. It's the first dinosaur name.
Yeah.
Also, that would be the worst.
Yes.
If it was what was the first dinosaur ever named? And instead of getting to say Megalosaurus, which is awesome, we had to say scrotum.
Yes.
And now we have to explain it.
Yep.
And now we have to go through a whole story.
It feels like there should be a caveat in the rules for, no, when a name is utterly detestable, we just get to not.
Let's just not. Fortunately, in this case, there are just a list of reasons why this is not a thing that needs to be taken seriously. It is, however, very funny.
Yeah.
Thank you, Leo, for asking that intriguing question. We hope that was informative. This has been a very historical episode. Listeners, like I said, if you'd like to learn more about this or any of the other topics that we talk about on the podcast, check out the blog. Go down to the episode description and head to our website where you can read the blog post for this episode with images and links and stuff like that. Also on the website nowadays, there is an announcements section on the homepage where we'll announce upcoming stuff, like our upcoming Spotlight 2024 series. Keep your ears out for that. Also, next episode is 185, which means Allie's coming back.
Woo!
So that's something to look forward to. A big thanks, as always, to the people who requested this episode, to request all of our topics, to our new patrons, to our old patrons. If you have a subject you'd like to hear us talk about on the podcast, head to our website. There is a topic request form where you can submit a request yourself. And we will perhaps get to it as we work our way through our enormous and fantastic list of episode requests. Special thanks to our top tier patrons, Danielle the Bug Lover, Sarah May, Robert Mart, Kit Kat Kocha, and Quinn Ferguson. Thank you all so much for your extra incredible support. We release episodes every fortnight. That's every 2 weeks. There's more episodes to come. Like I said, next week, plants. Our next episode, Plants with Allie. And then there will be more after that.
Yay.
Happy Darwin Day, everybody.
Happy Darwin Day.
I feel like I forgot to say that at any point during this whole episode. This has been our Darwin Day episode, our historical figures episode. Happy Darwin Day. Darwin Day is February 12th. We hope that you enjoy it by doing some sort of Darwin. Go hug a barnacle.
Yeah. Put a beetle in your mouth.
Go put a beetle in your mouth.
Pretty sure we've made that
for
joke
sure
before.
I was just about to say, for sure we've made that exact joke. In honor of Sir Richard Owen, go admire a whale skeleton and write a anonymous mean article about somebody that you don't like.
Go look up videos of lungfish.
Go look up videos of lungfish and be mad at Darwin.
Yeah.
Bye, everybody.
Bye.
Thanks for listening to the Common Descent Podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.